students, I welcome you in today's session of physics, and in physics in today's class we are going to discuss chapter number 7 of sound. Clear? This is your chapter 7 of physics, sound. So what is sound? The sensation felt by our ears is called sound. You can see here the sensation felt by our ears is called sound. Sound is that form of energy which make us hear. Clear? Sound is produced when a body vibrates. From where sound produced? Suppose that a sound wave is travel in a medium. What is medium? Medium is your air, sound, water and glass. You can say that through which sound is propagating. So when the particles of the medium vibrate, we hear sound. Like when a string of guitar, the skin of a drum, the hanging ball of a bell vibrates, they produces sound. Clear? Different vibrations of different objects make different sounds. The vibrations is defined as the rapid back and forth movement. Rapid and forth means go forward and backward of an object about its mean position. The sound wave that is created by vibrating particle. So sound needs a medium to travel. This is important line. Sound needs a medium. Medium means you can consider it air, water and glass. So this is necessary for the sound to propagation. It contains a medium. Now what are the characteristics of sound wave? Here are the some characteristics given. We will discuss about what are the characteristics. So sound is a longitudinal wave. I hope you are familiar with the longitudinal and transverse wave, because there are the two kinds of wave. One is transverse and the other one is longitudinal. So sound is a longitudinal wave which consists of, and in longitudinal wave what happened? We get here the longitudinal wave compression and rarefactions. So traveling through a medium. A sound wave can be described completely by 5 characteristics, that is its wavelength, amplitude, time period, frequency and velocity or speed. So all these characteristics of sound waves are described below. Here you can see that this is the figure. Considered a longitudinal wave. Here you can see this is the wave A, B, B to C and after that C to D, D to E. This is a sine wave. And E, F, G, H, I form by the vibration of a tuning fork. I hope you know the tuning fork. The first sound wave starts from the normal density position A. This is the normal density position A. And after going through the compression along A, B, C and rarefaction along C, D, E, it returned to the normal density position E. Clear? So the portion you can see here A, B, C, D, E. This the upper portion. This one A, B, C, C to D and D to E. What is showing here? Represent one complete sound wave. Fine. So it is showing the complete wave. The next sound wave is start from which point? You can see here the next sound wave is starting from E to F, F to G and G to here H, I. So this is the next sound wave. So the above figure shows two complete sound waves from A to E and after that from E to I. Clear? We will now describe the wavelength, amplitude, time period, frequency and velocity of the sound wave. What are these terms? So first we talk about what is wavelength. The minimum distance in which the sound wave repeated is called its wavelength. Clear? You can say that the minimum distance in which a sound wave repeats itself is called its wavelength. In most simple words, it is the length of one complete wave, or you can also say that the wavelength is a length of one complete wave. The wavelength is denoted by the Greek letter lambda. This is the symbol of lambda. In a sound wave, the combined length of compression and an adjacent rarefaction is called its wavelength. Means the distance between one compression and one rarefaction is called its wavelength. For example, in the figure 13, I will show you the figure number 13 in the below section here. After completing this, I will show you the figure. The length compression, it is written I think wrong. The figure is 7, not 13. So the length of compression AC and that of the adjacent refraction CE, you can see from the figure here. The compression is A to C, this is your compression, fine, and from C to E, which is the point of rarefaction. So the combined length A to E is equal to its wavelength. So you can say that from here, this one is your wavelength. From B to F, it is denoted by letter lambda. Clear? In a sound wave, the distance between the centers of the two consecutive compression or two consecutive rarefaction is also equal to its wavelength. I hope it is clear. Now we will come to what is amplitude. So when a wave passes through a medium, the particles of the medium get displaced temporarily from their original undisturbed position. Clear? So the maximum displacement, you can define amplitude from here. The maximum displacement of the particles of the medium from their original undisturbed position when a wave passes through the medium is called amplitude of the wave. You can see here on the above figure 7.1, the maximum displacement on either side, either on the above direction or downward direction. So this is your amplitude, this one. Fine. So that is the thing written here. The term amplitude is in fact used to describe the size of the wave. Fine. PB is the amplitude of the wave. You can see here in this figure, P to B, this one. I told you this is the amplitude, and in this one, this amplitude, this is also called amplitude. Clear? P is the amplitude of the wave. The amplitude of the wave is usually denoted by letter small a or capital A. I hope it is clear. Now we will move to time period. What is time period? So the time required to produce one complete wave or cycle is called its time period of the wave. Now one complete wave produced by one full vibration of the vibrating body. So we can write another definition of time period as follow, like this. The time taken to complete one vibration is called its time period. In the above figure shows two complete wave, one wave from A to E and the other wave from E to I. Suppose these two waves are produced in 1 second, then the time required to produce one wave will be how much? Half second or 0.5 second. So in other words, the time period of this wave will be 0.5 seconds. The time period of a wave is denoted by letter capital T. The unit of the measurement of time period is how much? Seconds. Fine. Now we will move to what is frequency. You can see here frequency. So the term frequency tells us the rate at which the waves are produced by their source. Fine. So the number of complete waves or cycle produced is called frequency of the wave. I hope it is clear. Since one complete wave produced by one full vibration of the vibrating body, so we can also say that the number of vibrations, you can define it frequency like this, the number of vibration per second is called frequency. Clear? The SI unit of frequency is Hertz, which is written as Hz, capital H and small z. The frequency of a wave is denoted by letter capital F, or sometimes it is represented by small n or nu. You can see here nu is also called frequency. So a sound wave that can be represented by a single frequency is called pure wave or monotone. You have to remember this line. The sound wave that can be represented by single frequency is called pure wave, or you can also define it, call it monotone. We will now give the relation between the time period and frequency of a wave. This is important thing. The time required to produce one complete wave is called its time period. I already told you what is time period. So let us suppose the time period of a wave is how much? T seconds. So now in T seconds, number of wave produced is equals to how much? 1. So in 1 second, the number of wave produced is equals to how much? 1 by T. But the number of wave produced in 1 second is called frequency. This is the definition of frequency. So this means that the frequency of the wave of time period will be T. How much? Frequency is equals to 1 upon T. This is the relation between frequency and time period. So we can now say that the frequency of a wave is the reciprocal of its time period. That is, you can write this formula here. frequency is equals to 1 upon time period, or f is equals to 1 by t. So f is the frequency and t is your time period. I hope it is clear. We hear many sounds around us in our everyday life. We hear sounds of conversation, telephone bell, radio, television, school bells, vehicle, instruments, various animals, and chirping of birds. Fine. So now what are the characteristics of sound, loudness, pitch and quality? We will now discuss this point. So a sound has three characteristic properties by which it can be recognized. These are their loudness, pitch and quality. Two musical sounds may differ from one another in one or more of these properties. So we will now discuss the three. Here you can see there is an experiment given below. The vibration of the strings produced by a string, the vibration which are produced due to the string, you can see here. So what happened, we will discuss here the three properties, characteristics of sound in somewhat detail. So first one is your loudness. What is loudness? So the sound are produced by vibrating objects. If more energy is supplied to an object by plucking it or hitting it more strongly, then the object will vibrate with a greater amplitude and to produce a louder sound. Thus, the loudness of the sound depends on the amplitudes of vibration of the vibrating object. Clear? Now, greater the amplitude of vibrations, louder the sound will be. For example, when a sitar string is plucked lightly, then it vibrates with a small amplitude and produces a faint sound or a very feeble sound. On the other hand, when a sitar string is plucked hard, it vibrates with a large amplitude and produces a very large sound. This can be shown here in the figure number 7.2. You can see here the amplitude in the first one is very small because here we pluck the string with a very feeble force. Clear? Now see the figure B. Here the amplitude is quite large. Fine. So this is the difference between both the two. The same experiment they perform here with the pendulum ball. You can see here thread is small thermocol ball and a steel tumbler. Fine. Now we will come here. From the above discussion, from the experiments, we concluded that the loudness of the sound depends on the amplitude of vibration of sound producing object. This is important one. So when the amplitude of vibration is large, the sound produced is loud. On the other hand, when the amplitude of vibration is small, the sound produced is very feeble or very faint. Actually, the loudness of sound is directly proportional to the square of the amplitudes of vibration. This is important line, you have to remember what is the relation of loudness. So you can tell them the loudness of the sound is directly proportional to the square of amplitude of vibrations. This means that the amplitude of vibration is double, 2 times, the loudness will become 4 times. Fine. If you increase the amplitude of vibration, then the loudness will become twice. Look at the second one. And if the amplitude of vibration is half, then the loudness will become 1/4. This is important point for your examination point of view. So just remember it. The loudness of sound is expressed in the unit is decibel. Decibel is a unit which is used to measure the loudness. So the symbol of decibel is dB. The softest sound which human can hear is said to be loudness of 0 decibel. Clear? The loudness of sounds coming from the source of common source of sound around us are given on the next page. You can see here the sound and their loudness given in here in the chart. So you also remember this chart, how much sound produces by different objects. Now the thing written here, a loudness above 80 decibel, the sound becomes physically painful. Means if you hear the sound 80 decibel, then pain is starting in your ear, and about 140 decibel sounds hurts too much. Fine. I hope it is clear. Now we will talk about what is pitch. So pitch is that characteristics of sound by which we can distinguish between different sounds of the same loudness. It is due to pitch you can identify that girls and boys. So for example, we can distinguish a man voice and a woman voice even without seeing them. This is because the man voice and a woman voice differ in their pitch or shrillness. Clear? A man voice is flat, having a low pitch, whereas a woman voice is shrill, having a high pitch. The pitch of sound depends on the frequency of vibrations. In fact, the pitch of sound is directly proportional to its frequency. If the frequency of vibration is low, clear? So the sound produced has also low pitch. Fine. On the other hand, if the frequency of vibrations is high, the sound produced has high pitch. A man's voice has low frequency, so it has a low pitch. A woman's voice has high pitch. The voice of a small baby has a higher frequency than the voice of even a woman. So the pitch of the baby voice is higher than that of a woman. Thus, the sound of low frequency are said to have a low pitch, while the sounds of high frequency are said to have a high pitch. Clear? As you can see here, this is an experiment given. A sound having high frequency or higher pitch is said to be shrill. So the voice of women has a higher frequency or higher pitch than that of a man, due to which the voice of women is shriller than that of a man. Clear? The voice of man having low frequency or low pitch is said to be deep or flat. The voice of a small baby has higher frequency or higher pitch than that of a woman, due to which the voice of a small baby is even more shrill than that of a woman. So it is the frequency of vibration of the sound producing object which determines the pitch or shrillness of sound. As the frequency of vibration of an object increases, the pitch or shrillness of the sound produced by it also increases. So when we go from a man to a woman and then a small baby, the frequency of vibration of their vocal cords increases due to their pitch. So when we switch on a table fan, we can hear the increase in the pitch of the sound produced as the speed of rotation of fan or rotation increases. You can see here the example given of a drum beating, a person beating a drum here. You can see that the membrane of the drum vibrate with a low frequency. Therefore, drum produces low pitch sound. On the other hand, the air in a whistle vibrate with a higher frequency, due to which the whistle produces a sound having higher pitch. Clear? The sound produced by a whistle is said to be shrill. A bird crow makes a high pitched sound having high frequency, whereas a lion makes a low pitched roar having a low frequency. So the roar of lion is however very loud, whereas the sound produced by a bird is comparatively quite feeble. Clear? So we can show the relation between frequency, pitch of sound producing object or vibrating object by performing a simple activity as follows. Clear? So you can perform this activity the person is doing here. I am ending this lecture, students. Our next topics or the remaining topics I will discuss in the upcoming lecture. Till that, thank you class, thank you very much.